So and just to clear this up, so the interview format will be it's an hour long, but
Okay.
unlike a real interview, we're gonna just go right into the interview. Usually, there's gonna be
Mm-hmm.
5 minutes at the start for introductions, but we'll save
Mm-hmm.
that for the end. We'll save that for the end if you're still interested. And at the end of the interview,
Okay.
there's usually 5 to 10 minutes of any questions that you have and any questions
Mm-hmm.
that the interviewer wants to clear up with you as well. So realistically
Okay.
speaking, you have about 45 minutes of actual coding time. Okay. So today we're going to
Okay.
spend 45 minutes coding, and then we'll spend the rest of
Mm-hmm.
the time giving feedback for your performance and any questions you might have. How's that sound?
Oh, sounds good. Thank you.
Okay, great. So I see you're in the coder pad already. What's your preferred language?
Python.
Python's good. Okay, great. So what's going to happen here is I'm going to read a question to you, and you are free to take
Mm-hmm.
notes. Just right here if you
Okay.
need. And then anything you might have as a question or clarification, please let me know. Okay.
Sorry, I think I cannot edit this.
Oh, I see you adding. I see you adding stuff right now. Do you
Is that
know?
is that me?
Yeah,
Is that
this is
me? Oh,
that's you.
I was thinking it's you. Okay. Okay. Cool. Thank
Okay,
you.
great.
That sounds good.
Okay, great. Okay, so for this problem, I would like you to implement a method or function called merge two lists. Okay, so I want you to implement this merge two list function. Okay, the input is going to be it's going to be two inputs. One input is the head of a linked list. Okay, and so you can write that down. It's a head of a linked list,
Other one.
and the other input is also a head of another linked list. So they're two different linked lists.
Okay.
Okay, and what I'm telling you, okay, that these two lists are already sorted in increasing order. Okay, and I would like you to return me the head
Mm-hmm.
of a linked list that is that is merged in maintaining the sorted order.
Return the head of the sorted
Yeah, of the merged lists.
merged two lists, right?
Yes, that's right. Yes, exactly.
Okay. Is there any other thing?
No, that's all. But I will give you the definition of a node. You can use that,
Okay.
or you can make up your own. That's fine.
Okay, sure. Link node. I'm going to make it a note and then make it shorter. So for example, if you have a list one and the list maybe one, two, four, five, and you have another list which is two, you might have one, three, and six maybe. Then after you get it, the result's supposed to be the head of the list three, where the list three will be, I mean, when I say list is a linked list,
Yes, yes.
will be one, two, three, four, five, six. Is that correct?
Yes.
Okay. Um, so do you want me start coding right away, or you want to hear what I think?
Are you confident in your solution? Are you confident in an idea? Okay.
Yeah.
Okay.
I think first of all, I will make a dummy node
Okay.
so I can start linking, and then I will have like a 1.2 pointer to both the head pointer head of the each link list, and then I'm just using these two pointers to compare their value, and then my dummy node will be linked to the node with a lowercase, and then that pointer of that list, they will move to like proceed to the next node, and then and then we continue the compare stuff and then give the linking.
Okay.
Does that make sense?
Yeah, that sounds good to me.
Okay. Let me think about. The function will be defined as a merge list, and then I'm going to have a list one, which will be the head one, head 2, and then I think that's a definition. And then in this case, I will be first create my dummy node. I will call it current. So current will be the node of, since it's a dummy, I just put the default value.
Okay.
Oh, okay, I'm going to just comment out.
Yeah.
And I'm going, because we want to return the head of this merged list. So I'm going to save the head. Oh, maybe it's a keyword. So maybe uh, make a head to point to the current. So after, because the current pointer will move along once we join the list, then
Yeah.
once we are done, we can just return the head, stuff like that.
Okay.
Okay, oh, I'm going to get a pointer current one, which pointing to the first list, and then current two, which pointing to the second list. And then I will go with while loop, while both of the current one and the current two, oh, sorry, both of them is not known, means that the node exists. Node and not current two. So, well, okay, is that the why it has arrow? Can you just keep coding
Yeah, it's an error
the
because
logic?
this is not a valid block yet, so you need to have a code there. Yeah.
Ah, okay. So well, the current one and the current two, they all exist. We want to compare their value. So if current one, the value is less or equal to current two's value, we want to get the dummy node link to the current one value, which is a smaller one.
Mm-hmm.
So I'm going to current dot next equals current one, and then current one, move the current uh, to the next node, current one the next.
Okay.
And then after that, I think I need to move the current as well. Current dot next.
Okay.
And and else, if the other case means that current choose value is less than current one, so in that case, we basically need to repeat the same procedure, but change the current one to current two. The I think this way we can go get to outside of the stuff current dot next. This is basically the logic, but
Mm-hmm.
there is a other case that they are different lengths of the list one and the list two. So one of them might finish earlier.
Okay.
So for example, if the list one is just this one, like a 1, 2, and then once we done that, our current probably in the 2 position, and then there in the list 2 we still have 3 and 6. So in that case, we need to know like um, if current one finish or current two finish, and then we link the current to the one haven't finished yet.
Mm-hmm.
Does that make sense?
Yep. That makes sense.
Okay. So here we need to check if current one is not finished. Then we need to current dot next equals to current one. And the same thing for the current two. And then if current two not finished, we will just link the current to the current two. And then, oh sorry, current two.
Mm-hmm.
After that, I think we finish connect the list, and then next we need to return the head of the next. I
Yeah.
think that's yeah.
Okay.
Let me double check. Current guideline current. Yeah, I think that's a solution.
Okay. Okay. Can we just quickly run through this example that you just wrote over here, just to track the inputs and the values?
Sure. Do you want me to do it?
Yeah.
Okay.
So you can just pretend as if. So we don't actually need to run the code, but I would like you
Okay.
to walk me through what the variables would be, and what each of these things would do to the variables.
Oh, okay. I don't need to code it up. I just
No.
need to
So
like
just
walk
tell me.
through
Yeah,
the
just walk
code.
it through it with me.
Okay.
Yeah.
Okay. So when we first one, the first one, current one will be pointing to one location, and the current two. Okay, hold on a second. I'll say when we beginning, the current one will be here.
Yeah.
Then the current two will be here, and then when we come here, we have a current node which is pointing to current will be empty list,
Yeah.
and then the head will be empty list. Then once we started go into the loop, current one and the current two, they are both not known. So we check its value. If a current one value is
Sorry. Could you?
less
Sorry.
or
I want to
equal.
just want to slow you down just a second there. Sorry for interrupting. While they're what? Sorry. Could you just could you say that again? While they're not none.
Well one and the well current one and current two both pointing non-node.
They're both pointing to a node.
Yeah. It's like currently they are pointing to the head of the list, which
Right.
is
So what
the
is
one.
not? So what does not cur one evaluate to?
Oh, sorry. Okay, yeah. In that case, it's well current. Sorry. Yeah, it should be well current. Oh, yeah, it's a logic is all wrong. Yeah, I think yeah that makes sense. Okay.
Okay.
It means that well current one pointing to something not known and current two pointing something not known. Yeah,
Mm-hmm.
and then they go into this loop,
Okay.
and they once they find that the value current one's value is then the current will pointing to the one,
Mm-hmm.
sorry, one, and then the the current next will be current one, yeah, which is correct, and then current one can be two. I'm going to do this way. Current one now will be pointing to two, and then current one pointing point two, and then current is also going to the next one, which is pointing to. So, but where I should put the list, like I should put it here.
It doesn't matter where you put it. It's fine. I understand.
Oh, okay, yeah. And after that, currently we run this code current equals current next.
Yes.
So now current is pointing to the two, and
Mm-hmm.
after that we want to. Oh, I will just write current two here, point to one. So in the next loop, they also not known. And in this case, current two is one and the current one is two. So we link this, we link current next to the current two. And then we update the current two to the next one and then current pointing to the current
Yeah.
three. And then we go to this loop. And then we find y current y is smaller, then we sorry where I lost.
It's okay.
Oh, sorry.
Yeah,
The before is 1. Sorry.
yeah. There you go.
Now, right now is the current one is 2. So we want to attach the link current to the current one. And after that, we update the current one. Right now, current is none. And the current, current one will be pointing to none. And then current will be uh, moving to pointing to 2. Yeah. And after that, and we go when we check this loop again, we find the current one is none. So we break this loop. We go checking. Current one is none. So we skip this if statement, and then we go to the second statement. Current 2 is now none. So right now current 2 is at 3. So the current next will be the current 2, which will link the rest of the current 2 to the list. And then once we return the head.next because there is a dummy node.
Mm-hmm.
Head is actually a dummy node pointing to this
Yeah.
linked list.
Yeah.
Okay. That makes sense. I'm sorry. Yeah. It should
That's
be
good.
not a current one, not node. Yeah.
Okay. Um, yeah. Yeah. I mean, like, I think that's fine to me. Let's talk about the time and space complexity.
I think the time complexity will be the big of will be the big O of m plus n. M is the length of the list 1 and n is the length of the list 2. And the space complexity, I think, is just 1 because we only have one dummy variable and all the link will be the original node. We only create one, like a dummy node.
Okay.
Okay.
Can you elaborate a bit more on the time? Why are we taking the sum?
Mm, because we basically need to iterate each node of 2 lists to check their value.
Okay. Okay, so that's n plus n, and then your space is O1 because your inner justification was what?
Because we link to the node,
Mm-hmm.
we just kind of like just reconnect all the 2 lists already. If we don't
Okay.
count the space of these 2 lists,
Okay.
yeah, so it means like no new space was used. The new space generated is only by the dummy node which we create here.
Yes, there was a dummy node there, and there were some local variables,
Yeah,
but
yeah,
yeah,
yeah.
that makes sense. Okay. All right. I want to move on to a second problem. We have time for that, so I'm gonna comment all of this out for now, and we'll just scroll down. Okay. So let's do a second problem here.
Yeah.
Okay. So for this problem, I want you to write me a function called top frequent. All right, top frequent, and
Top
this function, yep,
three.
top frequent,
Okay.
and this function, you're given a list of numbers. There's two
Numbers.
inputs, right? So one is a list of numbers, and another is an
Okay.
integer k.
Okay.
Okay, and you are to return me a list of numbers that represents the k most frequent numbers in the list.
The K most fre frequent number in the list.
Correct.
Hmm. Okay. Top frequent number. So I think if we say want to see the K most, my first impression will be the heap. So if I give you example, if we have the numbers, which is 1, 1, 1, 2, 3, 4, 4, 5, 5, we will, and you give me the K value, which is, yeah, I want, maybe in this case, is 2. and then top two most frequent. In that case, do I need to return? In that case, we will return top. You want to return list, right?
Yeah.
We can either return 1 4, or we can return uh yeah, based on how heap doing. Let me think, because there are many qualification, right? It can be 1 5 and 1 4. Oh, sorry, 5 4 5.
Mm-hmm.
So this are top two.
Yeah.
So which one you want me return?
For this, any of them are fine.
Okay. Um. So what if the k value is more than, if the k value is larger than, in this case, 1 2 3 4 5, it's larger than 5. Are we going to just return 1 2 3 4 5?
Yeah. Then you would just return just all the numbers. Yeah.
Okay. 1 2 3 4 5. Okay, yeah, I think I'm going to use a heap in that case. So the idea is that use a heap. So when the heap, how heap is work, like in the Python they use the main heap, main heap. So what I'm going to do is I'm going to first iterate through the numbers and
Okay.
then count like the frequency of each element. Then I'm going to have a map, and then I would use this map to generate tuple. So for this tuple, I was do I need to write it down? So
Um.
basically, I want to
No. You can.
generate a map with the ingredient, with the element and their frequency,
Okay.
say, and then if like an iterate through the map, and then we create a tuple,
Mm-hmm.
and the first will be the frequency of the. Actually, if we want to find the most, if we want to have the most, we need to have the negative number frequency, and then the second element will be the element, because we want to return the element. Okay, now the frequency element.
Okay.
Then after that, we want to push all the stuff into the list, which have all the tuples. And then after that, we want to heapify. Actually, before we heap it, we want to, once we have this, we want to heapify instead of like, actually we can heapify, and then we can just cut the length first element. How do you do that? Let me see. Think. Yeah, I'll basically pick the we use the slicing, because the heap is basically a list. We just slice the what's that? How to do the slicing? List of the tuple. We want to slice to 0 to n, which is k plus 1. Does that make sense?
Uh. Okay. Can you talk about, well, what's the alternative? So why are we doing a slice here?
Oh, sorry. Hold on a second. Okay. Okay. Yeah, I think I missed some steps. So once we get the list of tuple, we can heapify it.
Yes.
Heapify it. And then after that, we need to, yeah, because the frequency, we, yeah, oh, because right now we don't want to slice right now the list is including the tuples, not the element. So we basically need to have for loop,
Okay.
and to iterate and the element from the top to from the top, and then we can extract the element from each of the heap. Yeah,
Okay.
and we get the k element. Does that make sense?
Yes.
Like in okay. Should I start coding?
Yeah, you definitely can.
Do we have time? Okay,
Yeah, we
yeah.
have time.
Yeah, we have time. Okay, so the name of the function is define top frequency. Uh, top frequent, I would just say. And then we got numbers and we got a k. Then after that, we want to use, there is a map. We want to have the map called default dict, which they're int, start with int.
Hmm.
I import the default, okay, yeah, I default dict from collection, I think.
Okay.
The, oh, why is not working? The, is I capital? No, I don't think it's a capital.
It, sh-
Collections?
it should be from collections.
Oh, yeah. Oh, okay. Okay, sorry. Yeah, after that, we iterate through for I in for number for I in range range length of the numbers. We want to increase it. So the map dot the call the numbers I, which is the value of element, and we want to increase it by 1. So this loop will do the frequency stuff. And then after that, we want to iterate to get the key value extracted. For key value from in the map dot items, I think that's
Yeah.
the function. And for the key, we before we need to have the list. How to do that? The heap list equal to we started at the empty list, and then we want to have the heap list dot okay, hold on a second. Oh yeah, append this one, and we want to have the tuple, which is a negative value plus key. Yeah, I think we want to input a value. Then after we get all of this stuff, we want to heapify it. So, oh yeah, we need to import heap. Heap, heap queue, yes. And then this heap queue, we want to directly heap the list. I did append, okay. Heapify, okay. Then heap list. After that, we have the heap list, which all the ingredient, not all the ingredient, all the element is sorted by their frequency in the descending order because we negative their frequency. So after that, we just iterate through the list. For I in okay, should I use a k? Yeah, for I in range k, I would like to, because k is an integer, right?
Okay. Yeah.
Okay. So yeah, In that case, I want to element, we extracted element. Actually, I'm going to extract each one. So frequency and the value, we extracted from the heap pop. So it will be what I call heap q dot heap pop, which will use the heap list. Then we got this element, and then oh here we need to have a result based to store the result. Then we I don't know why there is an arrow, but yeah, and then we append the value to the result. And then once we are done, we have the k element, and we just return the result. Okay, hold on a second. Let me check if I missed. Does that make sense?
Yeah, makes sense to me.
Okay. Yeah, I think that's the result.
Okay. Do you want to talk about the time and space?
The space we will have big alpha n.
Okay. And
Big O
and n is what?
space. Sorry, space will be big O of n. Sorry, because we have the dictionary and also we have create a new list. Not
Can
not
you
n.
can you tell me what is n?
N is the length of the numbers.
Okay. Okay.
Yeah, and then the time complexity. Let me think. Because heapify we will do here. Oh, sorry. Heapify will have iterate through will be a big O of n, and then heapify will big O of n, and then heap pop will be log n. So I think the time complexity is a big O of n.
Can you talk about the heapify part again? Sorry, the heap pop part again. What's the complexity there?
Because right now we have. Oh, sorry. Okay, sorry. Hip hop will just pop the first one, so the complexity will be the big O for one, not n, not log n. Yeah, hipify is no. Hip push is a log n. Hip pop should be one.
Okay.
Yeah,
And what and how many times are we doing that?
we do k times.
K times. Okay. So that's still bounded by. So we're saying k could be
Constant.
k. Okay. K. Well, k is k is an input parameter, right?
Yeah. We
Okay.
assume yeah.
And what's the most k can be? What's the upper bound?
K could be n then. So if that's the case, what's the scenario? It will be n as well.
Yeah. So does that change the complexity at all?
I don't think so. Yeah, it's still big O of n.
Okay.
Because yeah, this is a for loop will be big O for n, and this one big O of 1. So it in total it will be big O of n.
Okay. Um. Okay. We have a bit of time, so I want to ask you a follow up on this question. Okay.
Okay.
The follow up question is now my earlier restriction about how you can return any of the tie breaks. So I'm on line 61, right? In this question, I'll let you turn any of the three tie breaks, but that's no longer the case. Okay. Now the rule is you must, if there's a tie, you must return the numbers in order that they first appear in the list. So in this case, 1 appears first and then it's 4. So in this case, you must return 1 and 4. For example, if this was 5, okay, then 1 and 5 appear first, so you return 1 and 5. Okay, does that make sense?
Yeah.
So now there's always guaranteed to be a unique first solution, and you must return that.
Okay. So in that case, I feel like a heapify is the newest added elements. It will be always replace the previous one. So for example, if we get the heapify, like say if we keep heapify it, and then the heap will be one, and then the next time when we heapify 5, and the 5 will be before 1. Then once we heapify 4, heap 4 will be before 5, and then we heapify 5 again. Then in that case, but here we heapify sorry. Can we just do a slicing? So
Can you elaborate? I mean, you can do anything you want, but it might be wrong. So can you elaborate?
oh, okay. Yeah, I'm not sure like how. Yeah, for my understanding, when
Mm-hmm.
you heap it,
Yeah.
if they have the same thing. Oh, sorry. I think
Same.
the first thing is like when you have the list. First of all, the dictionary, I'm not sure if the dictionary will check the order though, because we create a dictionary first,
Yep.
and then we extract the key values. So
Yep.
if there is no guarantee for the order, like the map will be like 1, 5, or 4. So in that case, if we don't know the map order of the key, we cannot know which one we heapify first.
Mm-hmm.
Isn't it? Isn't it?
Can you say the last part again, just so I make sure I understand that
Yeah.
better?
So for example, so here when we do this one in the map,
Yep.
we don't know the order, but we
Okay.
use this loop
Yep.
to append it to the heap list. So in that case, if we don't know the order of that thing, if we don't know the order, and
Okay.
when we heapify, we definitely don't know what the heap queue will be look like. So there
Yep.
is, in that case, we cannot get the ordered result by slicing the heap. I was thinking, oh, maybe I can slice the heap because based on the order they process the element.
Can you ever slice a heap?
Sorry, could you say that again?
So, so if I didn't, so from what you're saying there, it sounds like, and correct me if I'm wrong, please. It sounds like you're saying, if we didn't have this restriction of that the order has to be, tie break the way I said, you could slice the heap. Is that your implication?
Yeah.
Okay, can you just show me that really quickly? Like what do you mean by slicing the heap, just so I understand?
Yeah, so if that's the case, I'm going to um
I just want to make sure I understand what you mean by slicing the heap. So yeah, if you just demonstrate what that means, I can quickly see. So you have your
if
heap over here, right? You have a heap and it's heaped right here. So
yeah.
how do you process heap list in that case? Because
Uh
you chose to process it this way, right? Like you chose to do it this way.
okay.
But it sounds
Yeah.
like you have a different way. Can you talk about that?
I mean, I feel like the after we append it,
Mm-hmm.
we will do we will slice the result. Uh we also we don't need to okay, hold on a second. Often if that's the case, yeah, actually you cannot do that because it will be fixed. Yeah, there is nothing we can we only can get this result. We cannot access the other element with the same frequency. They only will include 1 or 2.
Right.
Okay. Okay, so in that case, let me think
But so
how we
before
can.
before we move on, so without this restriction, like with the current code, You're saying, so we're saying that we can't. So we can, so can in this case, can't, is it yes or no that we can slice the heap to get the
No,
correct result? We can't. Okay, and why not?
because first of all, you don't know if there is a tie or not. You
Okay.
cannot slice the bottom because the bottom will be the one with the lowest frequency, but it probably not the tie frequency.
Yeah. Okay. I think I understand. Okay. We can move on.
Did it? Yeah, I'm not sure if I say the correct. Like my thought is that since this tie, there will be a tie. The order of you heapify it, the earliest you get will be the last one. The top one will be the last element you add into the heap. And then I was thinking you can just slice the last k element, but I just forgot that the last k is including the ones not the top frequency.
Okay.
I'm not sure if yeah.
Okay. So do you have a way to think about the
Do we
correct?
have a time to think about it?
Not very
If,
much anymore, but if you have an idea,
uh,
I would like
uh,
to hear it.
okay, you want the order. Sorry, say that again. You want the order of the 1 5.
Yeah. So
So if we have the
we'll still want to return the most frequent elements. Okay.
okay, but
But
you identify element based on
right. So now, in addition to the fact that we still want to return either 1 4, 1 5, or 4 5, we decide the type between these three possible answers based on the earliest that they have been seen in the list.
the earliest. Okay.
Right? So for 1 and
Okay.
4, 1 seen very early, but 4 is seen very late. 1 and 5 are both seen very early. So that's why it wins. And 4 or 5 are both seen very late, obviously.
Top K.
So 1 and 5 are both seen the earliest, which is why we still want to return 1 5, but but technically 1 and 5 have the same frequency as 1 4 and 5.
Mm-hmm. So how do you do that?
Do you know how this works? So I'm looking at the heap list. Do you know how a heap uses the value?
Yes, they
How?
ordered based on the negative value and they sorted.
Okay.
Yeah, that's
And
why
what
we
and what
make
is
it a negative
yes? And what does your value represent right now?
frequency.
Okay. So can we augment this to represent also the position?
Oh, okay, yeah. Mm, yeah, we can include the hold on a sec. How could I know the index? Oh, yeah. So in that case, when we have this dictionary, we will include the position with the element as well. So like right now, we only have numbers with the frequency with the numbers. We want to modify it like the value will be the value of the element and its position, the earliest position
Okay.
they first see.
Okay.
And then once we heapify it, when we add to the heap list, we can add it to the negative value and then key value and their position.
Can you just quickly write a pseudocode for that? So what would this line become?
Okay, I think I will be like you wanted the most earliest.
Yeah.
I think this will be position. So I assume that they will heapify first by this value,
Okay.
and then by the position. Position is you want to increasing order. The earliest will be yeah. The mean heap should do that. We don't need to add negative it, and then the key, and then once they heapify it, yeah, that will work.
Okay.
Yeah, that what you want? Is that
Okay.
what you want?
And can you tell me, does would that change the time and space complexity at all?
No.
Okay, why not? That seems like we're doing more work. So
This one, I think the biggest contribution from time is the how many numbers you have in the in the numbers. Like this one is just a small space constant, which is 3. It's a
okay,
constant.
okay,
Oh
yeah,
yeah, that's a yeah, that makes sense. Keep the position here. Okay.
okay. That's a wrap. So let's end the mock here, and let's talk about the performance and any questions you may have. How's that sound?
Okay, that sounds good.
Okay, so usually for these, I like to ask you, how do you feel like you've done? What is your impression of this so far?
Uh, this is first my experience, so
Mm-hmm.
I'm really nervous before I started.
Yeah.
So I afraid of I will be stuck on a question and cannot move forward.
Mm-hmm.
But I think the question I did is okay.
Yep.
It's not because I'm good, it's because I have done this two questions
Okay.
before.
Okay.
So I won't say this in the interview, but I will
Right.
say it to you because
Yeah.
I feel like I was cheating.
Yeah.
And but the thing is, the way how I walk through it is better than I expected, and also for the position
Right.
is a new. It's I never see it before, but I feel like since I know how Hibify works,
Okay.
it helps when you give me the hint. So
Yes.
this is like really new. So I think I can work with you together to make to like get the solution.
Yep.
And I also think, yeah, I think the two question I write is correct answer and also the
Okay.
best solution. Yeah.
What's your okay? I won't comment on that yet. I'll comment on it after, but I will, but not yet. And how do you think you did on the time and space analysis? Time and space, in both in terms of correctness and in terms of the speed that you came up with it, etc. So how do you think you did on that?
I think I do it slow,
Okay.
but I feel like I doing it correct.
Okay. Okay. Let's talk about that. So, first of all, the first time, that's pretty good. Right? Let's get that out of the way
Okay.
first. That's
Thank you.
pretty good. So, just keep that in mind, right? But of course, we have to be a harsh critic so we can improve. But I want to just say that front that pretty good, right? Especially your first time. Okay, so keep that in mind. Um, Merge sorted lists. Now this is obviously a warm up. Okay, this is a warm up, and oftentimes if you go to an interview, especially like a medium sized interview, medium sized company, maybe a smaller company, um, they'll usually not open up with a super hard question because it doesn't benefit them if you get stuck right off the bat. So what I'm telling
Hmm.
you is, if you recognize the first question is a easy or like an easy medium, try to do it fast. Try to give the interviewer confidence that you know what you're talking about, that you're ready for a real question. Okay,
Okay.
so that's a bit of a tip for you there. Okay, um, yeah, the implication is correct. Obviously, you have that flipped out with a not condition. Um,
Yeah.
that won't really be a deal breaker, but that will be a case that you were asked to walk through the example and you missed it, right? So first of all, you said you were going to check
Okay.
it, you missed it. You were asked to walk through it, and then you still missed it. So missing it twice there is not a good look, but it's not too big of a deal. But just be aware of that, right? That even if you've seen it before, you still got to be careful because it's like that's a mistake which is very easy to tell, right? The interviewer can very easily spot
Mm-hmm.
that. Some mistakes are a bit
Yeah.
harder. This was a very easy one. Okay, so 100%
Okay.
interviewers will catch that. Otherwise, the coding was smooth, so it was pretty good. And you can definitely, if you're confident, again, go straight to the coding. Don't spend too much time volunteering to do extra stuff. If you're confident, go to
Oh,
the coding.
okay.
Time and space. So space is correct. Oh, one. Time was not quite correct. Okay.
Oh,
The
which
time
one?
the time complexity for the first one is actually the minimum of n plus n. It's actually the minimum of m and n. Sorry, not n plus n. It's the minimum of m and n. Do you know why?
Uh, oh yeah, because because we don't go through the rest of the
Correct.
longer one. Okay, yeah, that makes sense. Yeah.
And even if you did, it still wouldn't be n plus n. It would be the max of m and n.
Oh, okay.
Okay.
Okay, that makes sense. Yeah.
So that wasn't quite right. Okay. Okay. Second question. Now this one, by the way, a good interviewer, like we can tell you've seen this before, and the reason we can tell you've seen this before is because the logical like the train of thought jumps are relatively large. So how an interviewer would assess this would be okay. Emily here has done this problem as such. Has done the opening problem. Okay, this is an easy problem. I know what to look for. I want to get out of this problem as soon as possible because there's no skill here. I want to move on. Okay. But from your performance of the first problem, I have an anchor for how I think you will perform on the second one. And the fact that you completely skipped the sorting portion, you went straight to the heaps, means that either you're really familiar with heaps, which I will check, or you've seen a similar problem before, which is fine. Like that's not cheating. That's fine, right? So just be aware that most of the time, interviewer who has experience doing these problems, they know the levels of candidates and they know what to expect. Okay. Now let's talk about this question. This question you solved correctly. Okay, so this is without the follow up. The follow up we'll discuss separately. Okay, it's correct. Now, there's a couple things I wanted to talk about as well about this problem. When you see a problem like this, where it's like you said, it's a very generic problem, right? It's top k frequent, top x, blah blah blah. That's always a heat problem. That's not too hard. However, there are some intricacies. Like there are some things which you can actually show a bit of, like there are some differences that more skilled candidates can show. Um, One thing that threw me off right off the bat, for example, was that you were talking about slicing heaps. Now,
Oh,
my
yeah.
impression. Now, you never said, but I will say something. Not for you, but like in general, one thing I see a lot of candidates do as a mistake is they get the heap, right, and they say, "Oh, I want the top k." Return heap list up to k. Boom. A lot of people do that. Okay, this is wrong.
Mm.
This
Oh,
is
yeah.
wrong because this is the list is not sorted, right? You can only do this if the list is sorted,
Okay.
but the list is not sorted. So
Okay.
this would be considered incorrect. Okay.
Mm-hmm.
So when I hear someone, and any interviewer will tell you this, when someone says, "Oh, we're gonna slice a heap," that is red. That is red flags. That is alarm bells because you cannot do that without proving some invariance first. There are some
Mm-hmm.
considerations you can do this, but you didn't say anything like that. Okay. So that is a red flag. So you want to be just very sure that when you say something that you actually you
Mm-hmm.
thought about it a bit, and if you say something you
Mm-hmm.
want to say, oh, that's actually very wrong, you want to immediately backpedal. You want to say, oh, actually that's not going to work, and let me tell you exactly why that's not going to work. So in this case, you would likely say something along the lines of, oh, actually we can't slice a heap like that because the heap is not sorted in the way a sorted list would be sorted, right? And that would be like, okay,
Mm-hmm.
yeah, this person roughly understands the difference between sorting and heaps. So
Mm-hmm.
that's a big thing I'll say there is your communication was pretty close, like pretty good, but that's an example of where you probably didn't have experience with interviewing, and that's something which an interviewer would focus on because that is a very
Okay.
wrong statement to make. Okay.
Okay.
All
Mm.
right. So otherwise, I wanted to talk about um, you did know the about the min heap. That's good. You knew about the standard libraries. That's good. This problem, you would if you be using heaps like this, I would say most people will allow you to use counter. Have you used counter before?
Yeah. You mean like using the dictionary,
Yeah,
like
using
to
to count the
yeah.
frequencies.
Yeah, I just try because I'm more comfortable with the default dictionary because
Okay,
the counter I'm not really familiar, so I
no
just
problem.
use some. Yeah.
That's right. For future reference, it looks like this,
Yeah. Yeah.
right? So this is one thing which I'm saying this for two reasons. First of all, is you should always ask if you can use it.
Mm.
Okay, most interviewers, if the question is a bit easier, they'll tell you no, you can't use that. You can only use a regular dictionary. Um, but for some companies, if you don't ask this, they might doubt. Oh, does this person even know Python? Like if it's a Python role, right? If it's like a Java role, no one cares. If it's a Python, they might go like, oh, this person might not know the standard library very well, right? So if you just offer it, just casually, just offer it. That's very it's like a good signal. Okay, so
Okay.
if you
Mm.
know it, you should ask, right? And if they say no, that's not points off. That's not points off. That's just like, oh, this person knows it, but we don't want to test. We want to test it, right? That's fine.
Okay.
Otherwise, I want to talk about the heap again. So the space here is correct. You did not justify it correctly though, right? So it is ON.
Oh. Okay.
However, there were two things I needed to say. The first thing you needed to say was that the heapify function does not use like you didn't say how much memory this used. Okay.
Oh, because I probably don't know.
Well, yeah, and the interviewer knows that because they ask time and space. They like the interviewer knows where the time and space is, right? They're waiting for you to say it. Okay, they're not
Oh
stupid,
yeah,
right? Now,
yeah,
in
yeah.
this case, I'll tell you, Heapify is in place. It uses no extra memory. However, you didn't say it.
Oh, okay. Oh
You
yeah,
didn't
yeah,
say
yeah.
it, so that's still wrong, right?
Okay.
Um, what else did you not say? Also, this part was not correct. So what was not correct about this? It was you said heat pop is constant. That's actually not true. Heat pop is actually logarithmic in the size of the heap because it requires to maintain the heap
The
invariant.
re-
So it might require a
yeah, yeah.
heap up. Uh,
Okay, okay, I see. Yeah, I see what you mean. Because
so
after you pop it, you need to rearrange the rest
yes,
of it.
correct.
Okay, yeah,
So it averages also log size of the heap. So this would have actually
yeah,
been k log n, right? You did k. This is the size of n, right? If every worst case that's n, so that's actually k log n.
yeah. Okay, yeah.
Right. So that analysis was actually incorrect there. But again, because you said that heat pop was constant, you didn't lose all your marks because at least I know where you went wrong. Right. Everything else, the
Mm.
time was correct. So
Yeah, so,
a couple of things are right. Time was not very familiar. Okay, not very familiar with that one. You might want to check up on
mm,
that. Okay. And
yeah,
otherwise,
okay.
I have a couple other notes I want to share about the follow up. But before I go to the follow up, did you have anything else to say, or do you want me to just continue?
You can continue.
Okay. So the follow up here, this is a common follow up people will ask because they want to test your problem solving skills. When I saw you offer the heap solution, it is abundantly obvious that you've seen this problem before. Okay, that's okay. That's
Yeah,
okay. Then the test becomes: can you implement it fast? Can you analyze it correctly? Okay, and then to actually test your problem solving skills, because that's my goal. I want to test your problem solving skills. Is then I'll give you a problem you haven't seen before. Now, some really strong candidates have seen this variant too, but this is where, for example, you were struggling a little bit, right? You were struggling thinking about the solution,
yeah, yeah.
right? That's where I get a real signal about where your strength is, like how strong you are, like where you might be weak, where you might be strong. Couple things off the bat is that you use Python, but you don't use Python for full projects, and you don't use project at work. And I can tell you that, and if you do, by the way, don't take offense. This is just observations.
Mm,
Is because you do not use a lot of the common paradigms and the common assumptions that are available in Python. So one thing you said right off the bat, I think this is maybe the first thing you said. One of the first things you said when I gave the follow up is that because you're using a dictionary, the order you can't guarantee. Okay, that's actually not true in Python. In Python versions 3.6 and above, the insertion order for dictionaries are preserved.
oh, really?
Yes, yes, that's true.
Okay.
Okay, and actually in a lot of languages that's the case now, because it costs so little to maintain insertion order. It basically costs one extra node pointer per bucket, so it's very cheap. So yeah, you can go play with that afterwards by yourself. But that's actually an assumption that you're allowed to make. But you have to know it,
Okay.
right? You have to know it. Now in this
Yeah, I don't
case,
know that. Yeah.
that actually also wouldn't have helped you.
Mm,
The idea you were proposing wouldn't have worked unless you did a
mm,
lot of pre-processing. I mean, everything
mm.
can work, but it's just like what can you actually realistically do, right? The actual
Oh,
test
yeah.
here was, as you sort of noticed at the end, was how do heaps work? How does Python compare items, right? And as you know, Python compares items by using using the tuples.
Mm-hmm.
The conventional way to do this in Python is you acknowledge. So you have a key, you have a you have it named backwards, but you have a comparison key, and then you have a value which rides in the second element, right?
Mm-hmm.
In Python, the first value of a tuple is used as a what we call like a full length comparator. So you can put this here. You can put tie break one, tie break two, tie, and then etc. etc. You can put as many tie breaks as you want as further values in the first tuple to tell the default sorting algorithms or comparison algorithms in this case
Mm,
to use these as tie breaks. So the value is the same, then you use tie break one. If tie break one is the same, you use tie break two, etc. And it goes all the way down the first tuple. So this is the conventional way to do this. And by the way, this works for lists as well. So you can try this at home. You can do this with lists. So
mm-hmm.
this is sort of the intended method of doing this. And you would pre-process it, by the way. So you would just maybe, I don't know, you would just have a list like eco occurrence, right? First occurrence.
Mm-hmm.
Whoops. First. I haven't written Python in a long time. Occurrence equals
Yeah, that's
something like
okay.
that. Right. So
Okay.
you would track that separately, and that wouldn't cost you extra space because you would just put it over here, right?
Mm.
First occurrence at nums I equals I. Well, I mean,
Right.
if it doesn't exist, right? If
Mm.
doesn't exist, right? So that's sort of where you can track it for free, and where you would add it here for a default sorting behavior. So
Mm.
that's the sort of thing that people would expect you to come across and be able to figure out pretty quick if you are familiar with the sort of problem, because this is how you would solve any follow up with regards to tiebreakers, heap or not.
Okay.
Okay,
Yeah.
that is the feedback here. Any questions you might have? Otherwise, that's it.
Yeah. I think it's okay. I will come back later. But yeah.
Okay, then thank you for your
Uh,
time. Thanks for participating, and
Thank
good
you.
luck.
Thank you very much. I know. Sorry. Yeah, I do have a question.
Okay.
Like you you will write a note, right?
Yes, I have notes.
During the interview, are you able to like send it to me?
Yep, I can send this to you.
Thank you very much.
Okay. Take care.
Okay. Thank you. Bye bye.
Bye bye.